Welcome to Statistics chapter. Here we have exercise 14.1, fourth question. 30 women were examined in a hospital by a doctor and their heartbeats per minute were recorded and summarized as shown. Find the mean heartbeats per minute for these women. Choosing a suitable method. Their heartbeats and number of women given here in the form of table. Number of heartbeats per minute. Number of women 65 to 68, 2 women. 68 to 71, 4 women. 71 to 74, 3 women. 74 to 77, 8 women. 77 to 80, 7 women. 80 to 83, 4 women. 83 to 86, 2 women. Like that. Here we have the heartbeats and number of women. To that, here we have the solution to find the mean heartbeat per minute. Your solution. So, the given data is written in a frequency distribution table. Here we have total 6 columns because the data is in large size. To reduce the data size, here we are using the step deviation method. That's why 6 columns are required to solve the problem. Then the first column is here to arrange the class intervals. Number of heartbeats per minute we are taking as the class intervals, and the number of women we are taking as the frequencies. So the class intervals and frequencies are in this way: 65 to 68, 2 women. 68 to 71, 4 women. 71 to 74, 3 women. 74 to 77, 8 women. 77 to 80, 7 women. 80 to 83, 4 women. 83 to 86, 2 women. Like that. Here we have the heartbeat per minute and number of children. Then the next column. In the next column, we are taking the class mark to find the mean of the heartbeat. To find the class mark, here we are using the standard method, that is class midpoint formula. To find the class midpoint, here we are taking the lower class and upper class. So the lower class, upper class average, if you find, then we are getting the here. If you cancel that, 66.5, 66.5 is the class midpoint. We are taking the 66.5 midpoint as class mark for first class. Then the second class, 68 and 71, I'm sorry. 68 and 71 by 2, that is equals to 139 by 2, which is equals to 69.5. We make the calculation, we get the value 69.5. The 69.5 is the midpoint of 68 and 71 class interval. So 69.5 we are writing as the class mark. Then the next class, 71 plus 74 are the class boundaries. Lower boundary is the 71, upper boundary is the 74. So taking the average of the uh, lower boundary and upper boundary, by that we are getting here 145 by 2, which is equals to 72.5 is the third class midpoint. So the 72.5 midpoint we are taking as the class mark for third class. Like that, here we are going to find that remaining 3 classes or 4 classes. Boundaries midpoint 74 plus 77 by 2 for the next class midpoint. 74 plus 77, which is equals to 151 by 2. So 2 sevens are, 2 fives are, 2 sevens are, 2 fives are 0.5. So is a class midpoint of 77, 74 and 77. So we are writing the class midpoint 75.5 as the class mark. Then next one here 77, 77 and 80 average to find the midpoint of 77 and 80 by 2, which is equals to 157 by 2. 2 sevens are 40, 2 sevens are 40, 2 eights are 60, 0.5 is the 10. So 78.5 is the midpoint of 77 and 80. We are taking the midpoint as class mark. Like that, here we find the remaining 2 classes midpoints also. Okay. Then 80 plus 83 by 2 to find the average of or class midpoint of 80 and 83. So 163 by 2, which is equals to 2 8s are 60, 2 1s are 2, 2 5s are 10 point. So 81.5 is the next class midpoint. So 80 and 83 midpoint is 81.5. The 81.5 midpoint we are writing as class mark for the 80 and 83. Then the last one here 83 and 86. 83 and 86 by 2, which is equals to 169. 169 by 2. 2 8 is 16. 38.5 is 10. So 84.5 is the next class midpoint. So we are taking the next class midpoint, that is 84.5 as the class mark for 83 and 86. So after finding the class marks, we are observing the class mark in a larger size. That is why we are going for deviation method to reduce the data. So we are going to reduce the data, please observe here, by using the deviation method. So the deviation, by using the deviation method, we are going to reduce the data. To that we are using the formula B is equals to xi minus a. This is the formula for the deviation to reduce the data. Di is equals to xi minus a. Xi is the class mark and a is the assumed mean. Out of all these class marks, we are assuming one class mark as the mean. So here the frequency, highest frequency is here 8. That is why we are assuming 75.5 is the assumed mean of all these data of all the women. So by using the assumed mean, we are going to find the deviation. We are going to find the deviation. Please observe here. So class mark here 66.5 and assumed mean is here 75.5, which is equals to here 9, biggest value but is minus. So from 66.5, if we subtract the 75.5, then we will get here minus 9. Minus 9 is the first class deviation between the 75.5 and the 66.5. Then next class deviation 69.5 minus 75.5. So 5 minus 5 is 0. 5 minus 9, which means 15 minus 9 is equals to 6, and here that's it. So minus is the biggest value symbol. So minus means minus 6 is the next class deviation. Then the next class deviation here. The next class deviation 72.3, sorry, 72.5 minus 75.5. So from 72.5, if you subtract 75.5, then we will get here 5 minus 5 0. 12 minus 7, 5 minus 2 is 3. So biggest value is minus 3 is the deviation between the 72.5 and 75.5. Then the next class 75.5 minus 75.5, which is equals to 0. Then the next class 78.5 minus 70, assumed mean here 75.5, so which is equals to 3.0. So we are taking the next deviation for 78.5 and 75.5. The next class deviation 81.5 minus 75.5. 75.5. 5 minus 5 is 0. 11 minus 5 is 6. 6 is the next class deviation. Then next, the last class deviation is 4.5 minus 75.5. So 5 minus 5 is 0. 14 minus 5 is 9. 9 is the next class deviation. So like that, here we have found the deviations of all the classes. Minus 9, minus 6, minus 3, 0, 3, 6, 9. Then after observing the deviation, the data is smaller, no problem. Here with the deviation method too, we can solve the problem. But I wanted to give you more practice for the step deviation. That is why we are going for reducing the value into little more smaller. To that, here we are using the step deviation method, the step deviation is equals to, which means ui is equals to di deviation by height of the class, that is h. ui is equals to deviation, first class deviation minus 9 by height of the class. Before going to find the deviation, what is the height of the class? Please check here. Height of the class is equals to difference between the lower and upper boundaries. If you observe all the upper boundaries and lower boundaries, the common difference between the lower and upper boundaries is 3. So if you take the first class, 68 minus 65, which is equals to 3 is the height of the class, means class difference. Like that, 71 minus 68, 3 is the class difference. 74 minus 71, 3 is the class difference. Like that, if you observe all these classes, the common difference between the lower boundary and upper boundary is 3. That is why the common difference we are taking as a class width. The class width we are taking as the class height. Height of the class h is equals to 3. The next 3 ones are 3 3s are. So the step deviation for the first class is equals to minus 3. Minus 3. The next class, so next one, minus 6 minus 6 by 3, minus 6 by 3 is equals to minus 2. The next class step deviation minus 2, and next minus 3 by 3 is equals to 1. Minus 3 by 3 is equals to 1 is the minus is the value here. So minus 1 is the next class deviation. Like that, go for next class deviation. The next class step deviation 0 by 3, which is equals to 0, is the next class step deviation. Like that, observe the next class 2, 3 by 3, which is equals to 1. Next class deviation 6 by 3 is equals to 2. The next class deviation, step deviation, and 9 by 3, which is equals to 3, is the next class deviation. Like that, here we have found the, so minus 3, minus 2, minus 1, 0, 1, 2, 3 are the values, are the step deviations for the deviations. So if you observe the difference between the deviations and step deviations, the values are reduced, being reduced. So from 9 to minus 3, minus 6 to minus 2, minus 3 to minus 1, 0, 0, 3 to 1, 6 to 2, 9 to 3. Like that, values are reduced little more when we followed the step deviation. After getting the step deviation, here we are going to find the product of frequencies and step deviations to find the solution to the problem. In that way, product of frequency and ui, which means step deviation, that is 2 into minus 3 is equals to 6. Then 4 into minus 2 is equals to minus 8. 3 into minus 1 is equals to minus 3. 8 into 0 is equals to 0. 7 into 1 is equals to 7. 4 into 2 is equals to 8. 2 into 3 is equals to 6. These are the products of the frequencies and step deviation. So after getting the product of the step frequencies and step deviation, here we have to find the sum of the frequencies and step deviation. So minus 6, minus 8, minus 3, 0, 7, 8, 6. These are the values of the products of the frequencies and step deviation. If we go for addition between these things, then we are getting the sum of the FI is equals to 4, and the frequency sum we got as 30. So sigma fi is equals to 30 and sigma fi ui is equals to 4. So as we have discussed very clearly, before went for deviation, assumed mean is equals to 75.5, that is required in the solution. That's why here we are taking, and the class width, that is also required for the solution, for the solution group. Then mean heartbeats per minute is equals to x bar is equals to here a plus sigma fi ui by sigma fi into I. That is the formula to find the mean by using the step-deviation method. Once again, please after the formula, x bar is equals to a assumed mean plus sigma fi ui by sigma fi plus 1. That is the formula for step deviation. So in the step deviation, if we substitute all the values, then we will get the mean heartbeats per minute. So assumed mean x bar is equals to, here we are finding the solution to that one. Check here. So step deviation formula, x bar is equals to a plus sigma fi, I'm sorry, fi u, sorry, fi ui by sigma fi into h. This is the formula for step deviation. Yeah, we got the values. Assumed mean value we observed as 75.5 plus sigma fi value we got as 4, and here sum of the frequencies, the question that is given, and we have found to the sum, that is 30. Then height of the class 2 we have found as 3. Then if we calculate this one, 3 ones are 3, 10s are, so 4 by 10 we can write as 0.4. 75.5 plus 4 by 10 we are writing as 0.4. When we have a number 10, 100, 1000 in the denominator, directly without cancelling the numerator and denominator, we can directly write the decimal values. So here we got the 75.5 and 0.5. By adding those two numbers, we will get here 75.9 as the mean of the values. So, next step here. Here we got the 75.9 is the mean of the observation. That is the mean of mean heartbeats per minute, which is equals to 75 point. That's it. Okay, is the solution to the problem. Mean heartbeats per minute. So, if you like this video, click the like button and share the problem to your friends, family members, and relatives, those who need this problem. And subscribe my channel. The subscriptions are boosting to me to upload